Good morning, good afternoon, good evening. Not sure when you're watching this video, but welcome to our first lecture of the flipped classroom for our remote learning weeks in geometry. Today we're going to be talking about the relationship between the area and the perimeter of similar figures. So to start off today, we're going to just do a little bit of a review of what similar figures are. We're going to start by drawing two rectangles. So in order for these rectangles to be similar, they have to have a proportional relationship. It means in order to get from, just say, the width of one to the other, there's one number that we're going to multiply by to get from the smaller width to the larger width. We're gonna make the width of our smaller rectangle 1. And then we're going to have a scale factor of 2 in between our smaller and larger rectangle. So our width of our larger rectangle must be 2. Now if we make the width or the length of our smaller rectangle 3, the width of our larger rectangle has to be 6 because our scale factor is 2. 3 times 2 gives us 6. Okay? So that's just one example of similar figures. The same shape, but the sides are proportional. And today we're going to be looking at the relationship between the perimeter and area of similar figures. So we're going to take the perimeter and area of our smaller rectangle and our bigger rectangle and see what relationships we can find. So, as you probably recall, the perimeter of a shape is just the distance around that shape. So the distance around our smaller rectangle is 1 plus 3 plus 1 plus 3. So the perimeter is 8. The perimeter is 8 units. Okay? The perimeter of our larger rectangle here is 2 plus 6 plus 2 plus 6, or 16 units. Okay, so as you can see, the perimeter of the smaller rectangle times 2 is the perimeter of the larger rectangle. So the scale factor of our similar figures is mirrored in the scale factor of the perimeter of our similar figures. Let's take a look at the area. My guess and your guess is probably that this scale factor will still be the same, be evident in our areas. So let's just calculate it real quick and see what we find. So the area is the length times width of a rectangle. So when we multiply the length times width of our first rectangle, we get 3 units squared. Okay. Now let's take the area of our second rectangle. We have a length of 6 and a width of 2. So our area is 12 units squared. Now, 3 times 2 is not 12. So the scale factor, the ratio, sorry, of the areas of our similar figures is not the same as the ratio of our perimeters. There's a different relationship there. And so that's what we're talking about today. How do we know what the ratio of our perimeters are in similar figures? And how do we know what the ratio of areas are in similar figures? So to quantify that, we have the main theorem that we're going to use for today's lesson. If two figures are similar with a scale factor of A over B, then their perimeters have a ratio of A over B. As we noticed, our scale factor was 1 to 2. The ratio of our perimeters was 1 to 2. We multiplied by 2 to get the perimeter of our larger rectangle. Now, the ratio, our areas of similar figures are going to have, is going to be the ratio of, now the ratio of the areas of our similar figures is going to be their scale factor, represented by A over B, squared. So the ratio of the areas of similar figures is A squared over B squared. Okay? So instead of multiplying by that same scale factor, we are going to square that scale factor in order to find the areas. Notice we multiply by 2, then 3 times 4 gives us 12. So that ratio is squared when we're talking about areas. So let's just do a quick application of this concept.